This is the geological history of Iceland, featuring Emma Harley. That's me. So, a little introduction. So, Iceland is located between Greenland and Norway at 63 degrees and 23 minutes north to 66 degrees and 30 minutes north, and around the Antarctic Circle and in the Greenwich Mean Time Zone. Iceland was formed from volcanic basalt around 25 to 20 million years ago. In total, Iceland has over 130 volcanoes, 30 which are active and 100 which are inactive. With the landmass around 40,000 square miles, it has a relative size of Hungary and Kentucky. This makes it second place for being the largest island, right behind Great Britain. So in this photo, you have the basalt, which is found in Iceland, and this is found along the coast. Alright, pre-Iceland, aka before Iceland was formed. So in the late Cretaceous to the early Paleocene, 70 to 60 million years ago, Greenland was moving slowly northwest and drifting over the hot spot. So this caused the hot spot not to be able to do anything because it couldn't pierce through the landmass of Greenland. It's basically this big fat thing just laying over the hot spot. So in the late Paleocene, which was 55 million years ago, Greenland eventually drifted away, and this caused massive amounts of basalt lava to be shooting up and cooled because of the ocean water. And this basalt is now found east of both Greenland and the Faroe Islands, north of Ireland, and west of Scotland. So in the late Eocene and the early Oligocene, which is 30 to 40 million years ago, animals used this land bridge that was formed by the basalt, and they would climb across the land bridge to get to and from Scotland and Greenland, or America and Europe, which was mainly between those two countries. So the origin of Iceland. So Pangea breaking up caused a hotspot formed around 100 million years ago during the early Cretaceous period, underneath where modern Iceland lies. So when I was talking about Greenland moving over the hotspot and being dormant, this is clearly way after the hotspot was actually formed. So the Eurasian plate and the North American plate diverge apart from each other in the Atlantic Ocean, causing magma from the mantle to swell up in the rift openings and over the rift valleys. So the cycle of rising and cooling caused Iceland to form around 24 million years ago in the late Oligocene. Overall, this makes Iceland more geologically complex than a simple divergent plate boundary. This is because it has both the hotspot and the divergent plate boundary. So the seafloor splitting along with the transform faults have conflicted with the tectonic plates for many years. This has caused the crust to remain thin within constant rising of the mantle plume. Basically what this is saying is that Iceland, when it eventually did form, it constantly has magma rising up and expanding, so from the volcanoes erupting, which I'll explain a little bit more later. So what exactly is a hotspot? So in this picture we have a hotspot underneath Iceland. It is the modern day hotspot that is found. And so hotspots are developed above mantle plumes, places where the mantle is extremely hot, causing it to upwell. Hotspot magma pushes through the lithosphere, causing active volcanoes to form on the surface. When the oceanic volcano plates gradually move further away from the hotspot, it causes volcanoes to cool down, and the aftermath of the cooling process creates islands, atolls, or seamounts. So this is an island created by the hotspot, which Iceland's plate it's on is since it's between Iceland's on two different plates, it's much slower moving than it would be if it was on like a constantly moving oceanic plate similar to Hawaii. So this is why it's one singular island expanding versus like multiple islands being created. So on the other hand, as continental volcano plates progress further and further away from these hotspots, it causes them to cool down and become extinct, which may happen in Iceland's future. So I just realized I forgot to explain the previous photo. So in this photo, the origin photo, it's an explanation diagram where the different ridges, rifts, magma flows, and plumes are around Iceland. So as you can see, it shows where the different rifts are, and then the plume is considered the central location and where the magma is arising. And then it shows the different ridges that are formed by the two plates separating. and it's just like a really awesome photo, and it shows the Faroe Islands, British Islands, and Greenland, so how it's formed in the middle. So the Tertiary period, which is the late Oligocene to the early Miocene, which is 24 to 16.4 million years ago. I don't know why I can't look in the camera. Approximately around 24 million years ago, the continents of Scotland and Greenland were progressing further and further apart, around 3 centimeters every year. The sea flowed over the land bridge between the two continents, eventually slicing it. So this is how the exact way Iceland was formed, and it was still over the hot spot, still being formed by the basalt, but since the ocean flowed over it, it split it, and that's how the little island was formed. So it forces the animals that were traveling between the two plates to settle on Iceland, and that's why Iceland has the creatures it has today. And the exact date of this happening is still quite unknown, but it's approximated around 24 million years ago, but they believe it's anywhere between 30 to 20 million years ago. So around 16.5 million years ago, the volcano active rift zone formed the oldest rocks in Iceland, and this rock was found in a borehole in the West Fjords parts of Iceland. So this picture explains the general location where Iceland was split from Greenland and Scotland. So as you can see, Scotland is over here, and Greenland is right here. It's big, fat, massive land. Now you understand why the hotspot couldn't pierce it. So during the Tertiary period, the Middle Miocene to Late Pliocene, which is 15 to 3 million years ago, constant eruptions started building the terrain of Iceland and in the last 12 million years. There were fields of lava, forests, lack of glaciers, lack of valleys, lack of table mounts, and lots of volcanoes. So around 3 million years ago, the Ice Age started with 30 cold periods and 30 warm periods. The cold periods lasted around 100,000 years, whereas the warm periods would only last around 10,000 years, which is still a very long time. So during the cold periods, magma would melt the holes in the ice, and the magma would hit the water, causing glassy sand and gravel to fill up these holes. And this material that was glued together and created in around 10 years of this constantly happening is called palagonite. And this has been covering Iceland for the last 3 million years. So in this photo, this is palagonite found in modern day Iceland. It's this brown, like muddy material almost, and it's formed a lot of the mountains and other terrains found around Iceland. So finally, in the history of Iceland, we have the Quaternary period, which is the Holocene, which these specific dates that I have is 12,000 years ago to 10,000 years ago, but it's actually 12,000 years ago to present. So around 10,000 years ago, the last cold period of the Ice Age ended, while the warm period started. The ice finally started to melt around 15,000 years ago. Iceland went without great glaciers for 2,500 years, starting 9,000 years ago when the last glacier melted in the last Ice Age, which was the warm period. So around 6,500 years ago, glaciers started to reform on the highest mountains in Iceland, and that's how it became glaciered over. So from there on, there were many volcano eruptions causing Iceland to expand and form more mountains. So this is the palagonite in the last slide, as we talked about. So this is the glacier found in modern-day Iceland. They believe it's a very old glacier. I do not remember the name of it, and even if I did, I couldn't pronounce it to save my life. So we're just going to skip that. So in present-day Iceland, we have an extremely active volcano site while having many earthquakes, because again, it is on that divergent plate boundary, so a lot of that movement is causing a lot of earthquakes, and then the volcano is the magma constantly pushing through. So the Eurasian and North American plates are still diverging apart, with the Iceland moving with the Harapur land in South Iceland that is moving with the North American plate. So what this is saying is they're still splitting apart and the land's moving with. So this is causing Iceland to split and the rift zones to grow bigger. So Iceland is moving, causing eastern rift zones to gradually take over the western rift zone by becoming the middle spreading area in South Iceland. So you can see that the western rift zone in the picture is getting much, much smaller, whereas the eastern rift zone is getting larger and larger and larger, and the focus, it's becoming closer and closer. So these are the three different rift zones, obviously, in the photo. And yeah. So what is going to happen in Iceland's future? So Iceland should stay volcanically active through the far future. Since Iceland's located on a plate boundary, it may split apart, causing it basically the Iceland to completely split. As you can see in the photo, this is already splitting in modern day Iceland. And in this case, the hot spot will cool from the ocean water constantly rushing on it, cooling it, cooling it, cooling it. And there will be no further volcanic activity in this area. Thank you for coming to my TED Talk.